Hi everybody, this is part 2 of the arrays video. Last time we looked at an introduction to arrays, and what you needed to understand, the most important elements are that arrays, an array is simply a bunch of memory locations with the same name. And each array element has a key and a value. Keys have to be unique, so you can't have any repeats in your keys. But the values don't necessarily have to be unique. Notice there's 2 oranges for the values, and each key points to that value. The way we define an array, there's actually 2 ways to do that. One is you can simply create a name, in this case vegetables, and the key is corn, the corresponding value is yellow. So when we reference this, we would simply type $vegetables sub corn, and that would return yellow. Alright, let me continue. We can also use the array, I say construct here, but it's a function. It's just a built-in function for PHP, array, and then again we point each key to the corresponding value using the pointer construct, I guess you could say that. So the pointer simply says this key points to that value. And we can do it using text-based keys, we can use numeric keys, or we can combine the two. It doesn't really matter. PHP doesn't care how you define your keys. You want to make sure that you don't define an array and then accidentally remove it using a reference to a scalar or a non-array, right? So this vegetables equals delicious will overwrite the vegetables array. The entire array is gone and lost. So you have to make sure you don't do that. Again, we talked about accessing them. So for this veg array, item 1 or key 1 points to squash, and so 0 points to corn, 2 points to leek, so we can reference them by saying, tonight I think I'll eat $veg sub 0, which is going to just return the value, which is corn. Same here. And then you can also define an array without explicitly stating the keys, in which case we start at 0. So this key, even though there's no key assigned here, it's assumed to be 0. So 0 points to sweet corn and asparagus, 1 points to lemon chicken, and 2 points to braised bamboo fungus. And then we can tack on elements at the end without explicitly enumerating the keys. So dinner sub nothing will append to the next available numeric key. So since we have 0, 1, and 2 here, this will be 3, this will be 4. And then finally, we finished up last time with the count and print r functions. Count simply tells you the number of elements in an array, and print r will give you a rough printout of what the array looks like. So again, back to this. If this is our dinner array that's been defined, print r dinner will print out all of the key value pairs in this sort of a format. It's not for production. But you can definitely use it, and you should use it for debugging your code. All right, so that's what we covered last time. So let's continue now, and this is extremely important because we're going to be using Foreach loops pretty much for the rest of the semester, and not just in this class, but in just about any scripting language. There's some sort of a Foreach construct. So let's start here with an array that's defined to be breakfast, lunch, snack, and dinner. Those are the keys. These are the corresponding values. And let me skip over the table part. Let's just focus on the Foreach loop. Foreach allows you to run through each element in the array. You start up with meal as, and then this is an arbitrarily assigned variable right there. So I just happen to choose the name $key, but you can choose anything. Whatever's on the left-hand side of this arrow is going to run through all of the different keys. So $key is going to take on breakfast, lunch, snack, and dinner. And $value, since that comes after the pointer, is going to take on walnut bun, you got it, cashew nuts, dried mulberries, etc., etc. So it's just going to run through each one of these elements and process them And as it does that, it's going to assign the key to the keys and the value to the value. So then if we go to the print statement, in this particular case I just choose to print it, it's going to print out key and value in that order. But again, we can switch it around any way we want, but it's going to print out a table row, table column or element, the key, which is breakfast the first time and walnut bun the first time. Then it's going to finish these up, print a new line, and then run the next loop, which is lunch and cashew nuts, and then snack and dried mulberries. So the output is going to look in your browser or at the PHP line, it'll look like this. It's again going to just run through each of those elements. So Foreach is a great way to just run through every element in an array without having to count, without having to set up a variable to keep track of where you are. It just does it automatically. And it tends to do it in the order in which the array was defined, which is nice also. Okay, so before I go to the updating array elements, let me just show you an example here. And this is we're gonna kind of review some of the things that we talked about last time as well. So I have this, let me just make this a little bit easier for me to access. In your week 4 folder, I believe it is, in the share elements, we have this animals file, and I've created a sound array, which cat points to meow, dog points to woof, cow points to woof for some reason. And let me just go right to printing it out. Remember, the print R function will just kind of display what the array looks like. So I'm going to write that out, switch to a different tab, and print it. And that's what it looks like, right? So again, keys on the left, values on the right. Okay, so let's add some elements to the array. Let's do sound sub duck is equal to quack. And let's just add some. Remember this this format for adding elements. If you don't define a key, it will take the next available numeric value starting at 0. So since we don't have any numeric values, this is just going to add sound sub 0, and let's just do a, I don't know, give me another animal. Let's go with tweet, and let's go with another sound. We'll do moo. If we print that out, okay, exactly as we expected, the key values, and then since we defined, we didn't define the elements, it just starts at 0 and works its way up. Interestingly enough, if I had done something like this, sound sub 8, which again is ridiculous, but let's say I had done that, then the sound underneath it is going to be sub 9. Alright, so it just takes the next available integer numeric index if we don't define it. Okay, how do we print out the size in an array? Well, easy. Print size of sounds is count sounds. Notice, since this is a function call, I can't put it inside the string. I have to break it out, separate it from the string with the dot operator, which is the concatenator. Okay, size of sounds. Did I mess that up? Oh yeah, it's supposed to be sound, not sounds. Let me clear this out. Okay, so size of sounds is 6, which is 6 elements. Good. All right, how do we modify an element again? Obviously, a cow does not woof, so we're going to do sound sub cow equals moo. And actually, let me just move this whole block up here. Oops, excuse me. Let's try that. I'll paste it in here. And now we'll print it out. And we'll see that if we define sound sub cow, we've already defined it up here. We can't have repeats for our keys, right? In other words, there can only be one cow as a key for this particular array. So this line here will overwrite this reference, and cow will now point to moo. Let's make sure. Sure enough, cow now is moo. And let's run a for each loop now. So we have this array sounds, right? So we're going to for each sounds as, and again, after the as, you have to have a key and a value, and use the pointer construct. And it's completely arbitrary. I get to choose what my two variable names are. So I'm going to call this one left, and I'll call this right. Even though that's a terrible choice of variable names, it's my choice. I get to decide that. So I'm going to choose left and right. And left points to the keys, right? And right is the corresponding value. So if I run through this now and I just print out simply left, comma, right. And you know what, I'm going to go up here, not to get, let me just erase the size part of this. Okay, so I'm going to print left, comma, right, try to predict exactly what prints out. It's going to be cat, comma, meow, dog, comma, woof, cow, comma, moo, duck, comma, quack, etc., etc. Let's just make sure. Oh, what happened there? Did I do something wrong? Maybe I didn't save it. Oh, and let me get rid of the print R also, since that's not something that we need to do anymore. Something's going wrong. Oh, I know. Same problem, same mistake I made before. My array is called sound, but for some reason I chose to do sounds. So that's why I was not getting any output. So change sounds to sound. Write it. Run it. Right. Left, comma, right. Left, comma, right. Left, comma, right. And that's all this is. It's not, there's nothing magical about it. You're just looping through all of the elements in sound, and whatever's on the left side of this pointer is the key, and whatever's on the right side of that pointer is the corresponding value for that key. Now let me show you something else here. I could just as easily have done this. And try to understand what's happening here. So again, on the left side of this pointer is all of the keys. Remember, we reference an array value by giving the array name and then in parentheses the key. So the first time through, left is equal to cat. So sound sub cat will return meow. Right? And make sure, this is extremely important. Make sure you understand that. If you understand nothing else from this video, make sure you understand that. So I'm going to write that out. And just to prove to you, clear, exactly the same output as before. So you have to be able to move between the keys and then the corresponding values, and you can access the values in two ways. You can either use this shorthand, which is defined just for the context of the loop, or the array reference, which includes the name of the array, parentheses or square brackets, and then the key. All right, good. So we've got that. What else do I want to do? I think we're probably good here. And of course, just to restate one more time, if I change this to Joe and Schmo, right? Then I can change down here to Joe, or actually, you can change things around back, different direction. You can do whatever you want with them. So this is going to print out what? Well, you tell me. What is this going to print out? It's going to be, remember, the key and the value are cat and meow. So if Joe takes on the keys and Schmo takes on the values, this is going to print out meow, cat, woof, dog, with dots between them, and exactly as we expected. Okay, so that's the first slide. Now, the next set in the notes is updating array elements. And you can take a look at this example. Let me try to do a separate example to clarify this. In the week 4 folder, there's also a file called curve. And what we have is a bunch of grades. All right, Joe, Bill, Sue, Ahmad, and Tony all have grades assigned, and let's just print these out using a print R to verify. I think it's, oh no, it's curve, right? All right, so that's what the array looks like. Joe points to 80, Bill's grade is 82, Sue's is 27, Ahmad's 59, and Tony is 40. Now let's run a loop. Right, for each grade as, and then a key value. So in this particular case, you probably want to be explicit about what the values represent. So we have a name, and then let's call it a score. All right, so name points to score. So the first time through this loop, Joe is going to point to 80. Then Bill is going to point to 82, Sue to 27, etc., etc. And let me do this. So it would make sense. Let's say we want to add 10 points to everybody's grade. All right, so we want to update this array so that Joe's grade is now a 90, Bill's is a 92, Sue's is a 37, etc., etc. Well, it would seem to me that, or it seemed to you probably at first glance that, well, score is all of the values, right? So it should make sense, and I'll do this the longhand way. Score, if you take score and you add 10 to it and then you reassign it to itself, it should work, right? In other words, if we're updating score, we're adding 10 to it and then reassigning it to itself. Makes perfect sense. In fact, well, okay, no in fact. Let's just get right to the end result. Let's print our grade again after the for each loop and run it. And what happens? Well, absolutely nothing. Notice we printed out the array, the grade array before the for each loop, and then we printed it out after the for each loop, and nothing changed. And here's why. Because when we're running a for each loop, the name and the score are only temporary local variables to that for each loop. So if we change score, we're not actually modifying the array, we're just changing the variable score, which is local to that for each loop. So it doesn't change the actual grade. If we do want to change the grade, what we have to do is, instead of using this, I'm going to comment this out, we have to actually reference the memory location. So the memory location, grade is the array, name is going to take on each key. So name, first time through, name is going to be Joe, then Bill, then Sue, then Ahmad. And so grade of each of those are the corresponding scores, right? Grade sub Joe is 80. Grade sub Bill is 82. And I want to add 10 to each one of those values. So grade sub name is going to equal, in the first time through, it's going to equal 80 plus 10, and it's going to reassign it so that's going to take on the value of 90, but it's going to stick. It's going to be permanent because we're not referencing this temporary variable, we're referencing the permanent grade array variable. And I think you'll see that, well, if we save this out and we run the program, the grades have in fact been updated. All right, so that's what this slide is trying to get at. You're not going to get a syntax error if you do this. All right, here we're just updating all the prices by 10%. It's not going to give you an error. It's just not going to have the effect that you want it to. You can't. So even though you can do price star equals 1.1, it doesn't affect anything. All right, so just keep that in mind if you ever need to update array elements, which you're going to need to from time to time. So hopefully that makes sense. And then finally, there's a short form of a for each loop, and let me show you with the, let's go back to the animal sounds. Here, I'll do it over here. All right, so instead of doing for each sound as a key pointing to a value, if we don't need to represent or use the keys for anything, if we just need the values, we can use the short form of the for each loop, which is for each, then the array name, as, and if there's only one thing after the as, it's assumed to be the value. So I'm just writing in the value explicitly as a variable, but again, we can choose anything we want, and we could do something like this: print the first sound, or sorry, the sound was value. All right. And so it's just going to take on each of those values. Be clear. Go back to that. The sound was meow, the sound was woof. Okay, so it's just going to refer to each of those values. All right, again, just to summarize, for each loops are critical to your success in this class. Arrays are critical to your success. So you have to not just view this video, but get in, play around with them, make sure you understand them. Maybe a good exercise would be, as you're working on your second project, to run a loop through each of the post elements. Because remember, $_post is just an array. And each one of those array elements has a key, right? That's the name of the attribute for the item on your form. So maybe play around with that and try to run for each loops and understand how to use a loop to write out the results for your form. Okay, well, good luck with this.